Hi everybody, today we're going to look at volume and do a little bit of revision on how volume works. Volume is the amount of space contained within the outer surfaces of a three-dimensional object. And the units for volume are measured in cubic units. We're going to focus on prisms and cylinders. So a prism or a cylinder has at least one cross-sectional area that's equal throughout the shape. So in the case of our cube here that I've listed, the top, if we cut parallel to the top and parallel to the bottom, every cross section, every face that we cut will be of equal size to the top and the bottom. Now similarly, we could have cut it sideways, we could have cut it across. With a cube, it doesn't really matter which cross-section we take, as long as it's not diagonal. Each cross-sectional face will be parallel to the faces on either side of it, and of equal size. Cylinders are a little different. If we did a vertical cut, on the far left-hand side, the cross-sectional area would be fairly small. As we get to the middle, it would be the biggest, and as we get to the end, it would be the smallest again. And we can see that here, if my little link works. Let's see if I can get it to work. Here we go. And I have a cylinder. And lo and behold, that shows the cross-sectional area if we do a cut. But if we rotate it around, it's going to work. And I move the cross-sectional area, we can see as we get towards the end, they change in size. Well, if they change in size, we can't use that cross-sectional area for determining the volume. We would like it to be in the other plane, this one, where the cross-sectional area, wherever we make the cut, is of equal size. So let's go back. So, to find those equal size cross-sectional areas, we have to have a look at our shape and see where it is. Once we've found the cross-sectional area, once we've found the plane that we can find the equal cross-sectional areas, we just take that cross-sectional area and multiply it by the height, and that'll give us the volume of the shape. So here I have a rectangular prism, and we can cut it horizontally, vertically, into the depth. It doesn't really matter which one, as long as we pick a cross-sectional area that's equal throughout the shape. And in this case, we've chosen the horizontal one between the top and the bottom. So the cross-sectional area of those cuts will be the base, 3 times 2. And to find the volume, we're going to multiply it by the other dimension, which is, in this case, the height. So 3 times 2 is 6, times 4 is 24 units cubed. That's the volume of this shape. Now, if we'd chosen the width and height, so this one and this one, so we'd be cutting that way into the shape. These two dimensions have already been used, so we'll use the third dimension to work out the volume. So 2 times 4 would give me 8, that'll give me the area of the cross-sectional area, and then times 3 to give me the third dimension. And in this case, it would be 2 times 4 is 8, times 3 is 8 times 3 isn't 24. 1 8 is 8, 2 8 is 6 down, it is 3 8 is 24. All's good. Now let's look at our cylinder. Now a cylinder only has equal cross-sectional areas in one dimension. That's between the top and the bottom. If we went to left to right, they wouldn't be equal, as we saw before. So we need to find the area of the top, multiply it by the height. To find the area of a circle, we use pi r squared. The radius is 3. Pi times 3 squared is 9 pi. Multiply that by 5, it gives us 45 pi units cubed. And if we wanted to, we could stick that in a calculator and get a decimal value. What's nice is that idea works for any old prism. So here we've got a house shape, and we know that the area of the front is 5 centimeters squared. We've already been given the area, we don't have to work it out. So we have the area of the cross-section, and that cross-section, if we cut all the way down here, we'll get the same shape. We'll get the same pentagon. Our third dimension is 10 centimeters, it's the depth of the page. So we can take the area, multiply it by the depth. The area is 5, the depth is 10. Multiply those together, we get 50. So the volume of this shape will be 50 centimeters cubed. Now, we don't always have a nice shape to work with, and we could do this problem many different ways. We could have worked out the area of the front face and then used the depth. We could have found the area of the cube and then subtracted out the cutout. But in this case, I think the easiest way is just to work out the volume of this top shape and then add on this bottom rectangular prism. So we've got a top rectangular prism, we've got a bottom rectangular prism, we're going to add them together. So to make my working neat, I numbered the top prism 1, I numbered the bottom prism 2 and put a divider between them, and then worked out the volume of each. So 3 times 3 gives me the front face, or the cross-sectional area, multiply that by the depth, that gives me 90 centimeters cubed. 3 times 3 is 9, times 10 is 90. Then we worked out the volume of the bottom shape, so that would be 8 times 4, which will give me the front, and then so 8 fours are 32, multiply 32 by 10, gives me 320. Once I have the volume of each, I can just add them together, and that gives me 320 plus 90, 410 centimeters cubed. So that's working it out as two different shapes added together, which we can do quite easily with composite shapes. Sometimes it's easier to do it as a cutout. You take the volume of the entire shape and then subtract the part that you're cutting out. So in this case, we're going to cut out a triangular prism on the inside of a cylinder. So to do that, we're going to work out the area of the cross-section and then apply that over the whole length. Now over here it said that the cylinder has a radius of 10 and a length of 50, so my triangular prism will also have a length of 50. Half of 4 times 3, that's the triangle on the front, so 2 times 3 is 6. 6 50s is 300 units cubed. Then we can work out the volume of the whole cylinder as if there wasn't a cutout. So we've told here the radius is 10. I'm not quite sure why I've put a radius of 5 in there, so I'll just fix this up while I'm here. Probably figure it out by the time I finish. So 100 times pi times 50. 100 times 50, 1,000, 5,000. Pi units. Take my 5,000 pi and subtract my 300. I'll have to get a calculator out to do that. Let's see. So I've got my 5,000. Now I need my times pi. Come on, calculator. And then take 300, which gives me a bit more than that. 15407.96 units cubed. Hopefully I've done that correctly now. Then we can continue. Alright, so the last bit of this is just to summarize the two formulas. To find the volume of a cylinder, it's pi r squared times the height. To find a prism, find the area of the base, and in this I've defined the area of the base as somewhere that's got equal cross-sectional area. And once you've found the cross-section, multiply it by whatever the other dimension is, whether it's depth, length, or width. Any will work as long as it's not been included when you're working out the area of the base. Alright, I hope that helped, and that's a bit of revision for you. Thanks everyone.